Okay, of all prisms. So here you have got the surface area. Okay, so that's the surface area, and then this is the volume. Okay, now let's start with the volume. Now, the volume is much easier. Okay, the volume you can calculate it by finding the area of the base. Okay, the general formula for calculating the volume of a prism is area of base times perpendicular height. Okay, so let me just write that down. So the general formula for calculating the volume is equal to area of base times perpendicular height. Right? That's how you generally calculate the volume of a prism. Okay? A cylinder is a prism. Alright? So, when it comes to a cylinder, what is the shape of the base? It's a circle. And how do you calculate the area of a circle?
Pi r squared.
It's what? Pi r squared. Don't forget that you were taught how to calculate the area of a circle in grade 8 and 9. So this is the base. That's the base. It's a circle. Okay? It's a circle. Then we have got the height which is perpendicular to that base. So the volume of the cylinder is equal to the area of the base, which is pi r squared, times the perpendicular height to the base. So the formula for calculating volume for a cylinder is this. It's pi r squared h. The pi r squared refers to the area of the base. The h refers to the perpendicular height. Perpendicular to what? To the base. The height is perpendicular to the base. So your volume for a cylinder is pi r squared h. So the volume is very straightforward. It is very simple. Right, let's come to the surface area. Anyway, before I move on to surface area, then, but we've got a question with regard to the volume there. I'm going to repeat this for the last time. The general formula for calculating the volume of a prism, its area of base times perpendicular height. So the base can be circular, in the case, it can be a circle like in the case of the cylinder, it can be a square, it can be a triangle, it can be a rectangle. Now your surface area now, this is interesting. Now with the surface area, what do we mean? We are, according to your understanding, if you talk about surface area, what do we mean? It's simple terms. It is the area of the outside of that shape. Okay? So, with the cylinder now, okay, remember it will be like this. Make sure you pay attention. Because most learners, they get to metric, they don't understand it. Well, this will come in metric when you do what's called differential calculus. Okay? So I've got my cylinder here. Okay? If I unfold this, right? Remember, when it's like this, when it's a cylinder, like that, the top is a circle, the bottom is a what? It's a circle. How do you calculate the circumference of a circle? Or the perimeter of a circle? How do you calculate the perimeter of a circle? How do you calculate the perimeter of a circle? What's the formula for calculating the perimeter of a circle? Have you ever done perimeter?
No.
Oh, because of COVID, you didn't get the chance. Okay. All right. The perimeter of a circle is equal to 2 pi r. It's 2 pi r, which means 2 times pi times the radius of that circle. Perimeter refers to the length of the circumference. Okay? Perimeter refers to the length of the circumference. The perimeter of a circle is equal to 2 pi r. So if you are to calculate perimeter, the radius has to be given, or you must be given the diameter. What is the relationship between the diameter and the radius? The diameter is 2 times the radius. The diameter d is 2 times the radius. So, this is the thing. If you want to calculate the surface area of a cylinder, remember it has got two circles, it has got a bottom and a top that are both what? Circles. Right? Now if I unfold it like that, each circumference becomes a breadth, am I right? Or a width. And then the height is going to become the what? The length. Are you following that? So, if I want to calculate the surface area of the cylinder, okay, surface area, right? So I'll start with the perimeter, which is 2 pi r, and that perimeter now is my breadth, or you can call it your length if you want. Then the height now becomes your length or your breadth, so this becomes 2 pi r h. Okay? But I didn't include the circles. How many circles do we have? 2. And what is the area of each circle? What is the area of a circle? It's pi r squared. I have already told you here. I told you already. Here. That pi r squared, that's the area of a circle. So if there are 2 of them, okay, in the case of a cylinder, there are 2. Okay, this is common sense actually. There are 2. We've got this top one here. And obviously we've got the bottom one there. So we've got 2 circles. So what is the sum of their areas? It's gonna be, it should be plus 2 times pi r squared. Okay? So this is the famous formula for calculating the surface area of a cylinder. Okay? That's the famous formula. So it's here. Surface area for a cylinder. 2 pi r squared plus 2 pi r h, or you can start by writing it as 2 pi r h plus 2 pi r squared. It's the same thing. If, let's say there's no top, okay, obviously it will change from having a 2 here to having what? Only one area of a circle, which becomes pi r squared plus 2 pi r h. If there's no top or there's no bottom. If you remove the top of a cylinder, the surface area changes. Okay? To what? To pi r squared plus 2 pi r h. And this is common sense. The top is no longer there, the bottom is there, the top is not there, you only have one circle. Am I right? Okay. If both of them are removed, because you can also get a question like that. If both are removed, it's common sense. There is no top, there's no bottom, like this. This is exactly what you have in the third scenario. There's no bottom, there's no top. So your surface area is going to be 2 pi RH. So there are three cases when it comes to a cylinder, but the general formula for the surface area is 2 pi r squared plus 2 pi RH, or you can write it as 2 pi RH plus 2 pi r squared.
So this is only for a standard cylinder.
Yes. This is the general formula for the standard cylinder. But you can have a special case where the top is not there or the bottom is not there. So you can have this first case here, when the bottom or the top is not there, the pi r squared plus 2 pi RH. If both the top and the bottom are not there, then your formula being 2 pi RH. Are you following? Huh? Can you answer me, please? Okay? So make sure you are familiar with this. You have to know this until the trick. Okay? Until the trick. Then, let's talk about the rectangular prism. Rectangular prism. The rectangular prism has got how many faces? Huh? 6 faces. Okay? So, if you want to calculate the surface area, you obviously have to calculate the area of each face. But the good thing is, some of the faces have the same area. If they are opposite each other, then they've got the same what? The same area. So, how many pairs of faces are the same? There are 3. Okay? So, let's start with this one. So you can start with any one you want, okay? I've chosen to start with that. So those two are what? They have the same area. You following there? Huh? Those two have the same what? The same area. So, if I consider B to be my length, then C will be my what? My breadth. Remember, the area of a rectangle is length times breadth. LB. But I've got 2 faces. Therefore, my surface area is going to be 2 times BC. Okay? If I consider those 2 faces that are highlighted. Why am I putting 2 BC? Because they are 2 faces, but they have the same what? The same area. What is the area of each one? It's B times C. Where B is the length, C is the breadth. There are no numbers. That's why you do algebra from grade. Are we together there? Okay, so I've dealt with the first pair. Yes.
Would you ever be a question where you have like a cylinder with no top or no bottom?
Yeah, you can have a prism as well, where you might have to remove the top, like this box here. It's a rectangular prism. This is a rectangular prism, one that I'm holding. So we are in maths. When you see this box here, it's maths that's involved. Maths. You hear me? This is mathematics here. The people who design these boxes, they know maths. Okay? The people who design this, they know maths. Not okay. It's done by engineers. They do the design. Might need some computer scientists to do the program, which will tell the machine the dimensions and all that. Maybe at the end you might need a human being just to put the tape and all that, but it can also be done automatically as well. And that involves maths. Okay? there's maths everywhere. You know, the other day I was talking to the grade 9s for grade 9 subject choices. If you are to do in everyday life, you want to do your financial budget, it involves maths. You look at your income, whichever source, whether you are a business person or you are working and you are getting a salary, look at your income, then you write down what you want to use the money for. You need to know the amount of each. You need to add maths, yes.
So then you are going to use the theory of Pythagoras, like in lab.
The theorem of Pythagoras is normally used in engineering. Okay? What do you mean this? I just told you already that we have got a prism here. We have got a prism. Maths here, measurement. We need to know the dimensions, length, breadth, and then you've got your height. There is maths everywhere. Sometimes, remember I told you, I'm not sure if you remember the trainer, maths involves problem solving, thinking, numeracy, knowing what? Numbers. And everything around you there are numbers. Even if you look at the windows here, there are dimensions. This room, it has got dimensions. It's a rectangular prism, by the way. This classroom. Yes. You're laughing. If you're an architect and you design a building, it's maths. You need the dimensions. Okay? The people who do the hands-on job of putting the bricks and all the cement, they are builders. To be a builder, I'm talking about a builder, you need some maths. Even if you are to be a plumber, you need what? Maths. Okay? To be a farmer, you also need maths. You need to know how many cows you have, how many goats, and all that. Right? And you need maths. Because being a doctor, you are a problem solver. The fact that there is some problem solving, you need to be very sharp. Okay, if a person comes to you, they tell you, okay, I'm feeling this. Quickly, you need to know, okay, it's this problem.
To be a good teacher.
Okay, let's not go on this. Okay, let's come here. So let's move on to the second set of faces. Okay, so I've used that, let me use that one. Now let's look at that bottom one and the top one. Okay? They have the same area. Okay? They have the same area. Now the question now will be, what is the length? What's the breadth? How do you think is the length and what's the breadth?
A is the length, B is the breadth.
A will be the length and B will be the what? The breadth. But there are two of them, so that will be 2A plus. The third set of faces, I think I like blue. It's my favorite color, by the way. So we have got that face. Alright. The other one, which is on the other side, okay, it can be a little bit tricky for me to shade it. Okay, I will interfere with the other color, but there are also what? Two of them. Okay, what's the length? What's the breadth?
A is the length.
A with the length and B with the what? The breadth. So this will be 2. Sorry, we are doing that one now.
C will be the breadth.
So A will be the length and C will be the what? The breadth. Okay. If you want to rearrange it to that, you can rearrange it. So it will be 2AB plus 2AC plus 2BC.
So the order matters when you add it.
No, the order is not important. Okay? Then let's come to the volume now. The volume of a prism. Okay, the volume of a prism, which is rectangular, like that. It's, in fact, I've already told you earlier that for all prisms, the general formula for calculating volume, it's area of base times perpendicular what? Height. So here, what's the base? The base, the area of the base will be what? AB. Are you following that? Huh? So, for our given diagram there, our area of our base is AB, then we multiply it by the height. What is the perpendicular height? What? C. So you can end up writing this ABC. Now, this can be simplified for a rectangular prism. We can write it as LBH. Volume is equal to length times breadth times the height. We can generalize it that way for a rectangular prism. Rectangular prism, okay? You can also do it if you have got a square prism, or in the case of a cube, you also have a cube which is more like a square prism, right? You can also write LBH, but now in that case the faces will be the same, the length will be the same. So you can end up writing as L cubed, or you can write it as S cubed for a cube. Okay.
Wouldn't you make it square, sir?
No, it's volume. For surface area, if it's a cube, then the area of each face will be S squared.
The surface area, the unit is in unit square.
Square, yes, square units. Volume is in cubic units.
Unit cube.
Okay, or units cube. So in terms of units, for surface area, it will be units squared. Whatever units you square them, for volume, it will be units, then you cube those units. Okay, those are there. That's how you write your answer in terms of whatever unit. So if it's surface area, units squared. Volume, units cubed. By units, there we are referring to millimeters, centimeters, kilometers, and so on. Okay. Are you following? Right, then let's do an example or examples. So we've got, for now, we do number 1 and number 2. So we'll do that one and that one. We'll talk about the triangular prism later on, yes?
So, let's say that we will give the formula.
Yes. No, we don't give you a formula sheet, but for questions on measurement, we give you the formula. But sometimes we can give you more than one formula. You have to decide the correct one for the given question. Are you following that? The formula will be given for measurement, including the coming test. Just what you are going to write next to. You are given the formula there, you need to make sure you use the formula correctly. So let's talk about this. So first, what are we supposed to calculate it? Okay, we round up to 2 decimal places, obviously. So it says consider the following 3 closed hollow prisms. So let's start with the rectangular prism. Number 1, we need to calculate the volume in cubic meters of each of the 3 prisms. Okay, so we're going to do number 1 and number 2. So we're going to calculate the volume of that prism. We'll start with the first one. So the volume, that's number 1. The volume of a rectangular prism is LBH. That's the general formula for a rectangular prism. Length times breadth times perpendicular height. Okay? So if you look at our diagram here, which one will be our length? 7. So this will be 7 times the breadth will be what? 6. Then the height will be 3. So that's 42 times 3, you get 126 The units there are centimeters, so that is the cubic what? Centimeters. Are you following? Then, number 2, calculate the surface area. Okay? Now, remember, this rectangular prism has got 6 faces. It has got 3 pairs that are equal in terms of area. So if I want to calculate my surface area, let me start with the top one. If it's the top one, then I'm going to have 7 times the breadth, which is going to be 6. But there are 2 of them. Okay? So I can put a 2 there at the beginning. Plus another 2 times. So I consider the top and the bottom. Then let's consider the face which is looking at us, facing us. Okay? So the length there is going to be what? 7. The breadth is going to be 3. Plus. Are you following? Huh?
Yes.
Then you look at this face here. That one there. And that one. What's the length? It's going to be 6. Right? And the breadth is going to be 3. Then you simplify this. So you get 84 plus 42 plus 36. So if you add 36 plus 84, you get 120 plus 42, you get 162 square centimeters. Or centimeters squared if you want. Okay? Okay, then number 3 says, if the cylinder or the cuboid, which is the rectangular prism, this is the other name of a rectangular prism. It's called a cuboid, but we don't normally use that. Okay, in everyday life, we normally use a rectangular prism, including in maths as well. But it has got another name, which is the cuboid. All right. Now, if you want to calculate the surface area with no top, okay? By no top means we are now subtracting for our case for this one here, we subtract one of those 2. We have to subtract the 7 times 6, which is 42. So to do that is very simple. We just say 162 minus 7 and 6. And then you are done. You get the answer. Are you following there? It's like this box there. There's no top. So how many faces does it have? 5 faces. The one at the bottom, okay, that's the only one. The one which is opposite it, it doesn't exist because it's not closed. So to do number 3, okay, let me do it at the top. To do number 3, all we have to do, we subtract the area of the top from the total, isn't it? So this would be, so it's a surface area with no top, okay? It's going to be equal to 162 minus 7 times 6. So that will give us 162 minus 42, and then you will get 120. Is that making sense? Huh? Or you can repeat writing this and that, then you say plus 7 times 6, you get to 120.
So that cylinder doesn't.
Yeah, according to number 3, it says if the cylinder and the cuboid, remember we are doing the question for the prism, the rectangular prism first. On the next page, I'll do the what? The cylinder. I started with the rectangular prism. The top is not bad. Does the volume change if the top is not there? Huh? No, the volume doesn't change, but the surface area can change. Okay, so let's do this one again, like how we did for the rectangular prism. So start with number one. We want to calculate the volume. So the volume of a cylinder, we are now doing that by the way, is equal to pi r squared h. Pi, you use the value on your calculator, so that will be pi times the radius. Now we have got the diameter there, so what will be the radius? And the diameter is in millimeters. So we have to convert the diameter into centimeters first. By dividing 90 by 10, you get what? 9. What is half of 9? 4,5. So this will be 4,5 squared. Right? Then our height is 5. If you use the calculator to do decimal places, what will be the volume? Tell me you've got your calculator. Pi times 4,5 squared times 5. Huh?
318,0.
Okay, so that would be cubic centimeters, or centimeter cubes. Then number 2, we were doing that, we're calculating the surface area. So the surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. Okay? So that would be 2 times pi. You can put that in your calculator, then the radius is 4,5 square that plus another 2 pi times 4,5 times the height, which is 5. Use the calculator, then what do you get? What?
268,61.
268,61. Now this is area, so it will be centimeters squared. Then to do number 3, that is the surface area if there is no top. With top open. The top is open means we only have one circle to take into account. So this will be pi r squared plus 2 pi r h. Now we can just subtract pi r squared from this. Okay? That's an easier way. Or we can just substitute into this formula here. But I'm just gonna subtract pi r squared from that. So that will be, this will be equal to 268,61 minus pi and the radius squared. You subtract that. What answer do you get? This will be 204,99. What's the third digit?
It's 988.
988. Okay. So that will be 9, 9. And then that will be 7 squared. Okay. All right.
Isn't it supposed to be minus on the?
Yeah, I put a minus.
No, for the blue.
Okay. The general formula is not supposed to be a minus. I say, if you want, there are two ways here. You can substitute into this formula here. These two come to this answer.
Oh, you
But I didn't want to waste unnecessary time. We already have the total area with both the top and the what? And the bottom. If there's no top, you just subtract the area of a circle. So I just did it that way, but you can also do it this way by substituting to that formula. Okay, you can verify, but